Hello, my name is Miss Jones. I teach elementary school math, and welcome to my channel, Miss Math Jones. Today we're going to be working on our third grade Eureka Module 5, Lesson 24 homework. The objective for our homework is to generate, that means to create, simple equivalent fractions. That means simple equal fractions by using visual fraction models in the number line. So we're going to create simple equal fractions by using pictures in the number line. Let's get started. So for this question, you're going to need two different color crayons or two different color pencils or your pencil and two different color markers just so that you can mark the different fractional units in different colors. So for this number line, we have an endpoint at 0 and an endpoint at 3. And number 1 says on the number line above, use a colored pencil to divide each whole into thirds and label each fraction above the line. So first, we're going to partition the top part of the number line into thirds, and then we're going to label the fractions. So let's place our first line about here, our second line here, and our third line here. Now notice, because we are partitioning into thirds, every 3 lines is going to be another whole number because 3/3 equals 1 whole. So every time we have 3 lines, then we have another whole number. So let's place another 3 lines and then we'd be to the whole number 2 because that's another 3/3. So place the first line about here, next line here, third line here, and now we're at 2. And we're going to keep going. So place one line here, one line about here, and our last line right here on the number 3. That's 3/3 again. That's another whole. Now we're going to label our thirds, and we're going to start at 0, and we're going to start by writing 0/3 above the number 0. Now, counting up, we have 1/3 above the first line. The second line will be 2/3. The third line is 3/3, and we know that 3/3 is the same as saying 1 because 3 divided by 3 is 1. The fourth line is 4/3. The fifth line is 5/3. The sixth line is 6/3, and that's also equal to 2 because 6 divided by 3 is 2. The seventh line is 7/3. The eighth line is 8/3, and the ninth line is 9/3, which is also equal to 3 because 9 divided by 3 is 3. Now, we've completed everything that we were supposed to do for number 1. Now we're moving on to number 2. Number 2 says on the number line above, use a different color pencil to divide each whole into 6 and label each fraction below the line. Now, as we've discussed before, sixths are half of thirds. So when you create your partitioning lines or your dividing lines for your sixths, make sure that you have one line in between the thirds and one line directly below the thirds. So let's go ahead and start placing our partition lines for our sixths. So the first line should be in between 0/3 and 1/3. The second line should be directly under 1/3. The third line should be in between 1/3 and 2/3. The fourth line should be directly under 2/3. The fifth line should be between 2/3 and 3/3. The sixth line should be directly under 3/3. The seventh line should be between 3/3 and 4/3. The eighth line should be directly under 4/3. The ninth line should be between 4/3 and 5/3. The 10th line should be directly under 5/3. The 11th line should be between 5/3 and 6/3. The 12th line should be directly under 6/3. The 13th line should be between 6/3 and 7/3. The 14th line should be directly under 7/3. The 15th line should be between 7/3 and 8/3. The 16th line should be directly under 8/3. The 17th line should be between 8/3 and 9/3. And the 18th line should be directly under 9/3. Now let's label our sixths. So we're going to start by writing 0/6 under the number 0. And we're counting up. So the first line is 1/6. The second line is 2/6. The third line is 3/6. The fourth line is 4/6. The fifth line is 5/6. The sixth line is 6/6. The seventh line is 7/6. The eighth line is 8/6. The ninth line is 9/6. The 10th line is 10/6. The 11th line is 11/6. The 12th line is 12/6. The 13th line is 13/6. The 14th line is 14/6. The 15th line is 15/6. The 16th line is 16/6. The 17th line is 17/6. And the 18th line is 18/6. Now, we've completed everything we were supposed to complete for number 2. And number 3 says write the fractions that name the same place on the number line. And here it is here. Now, if you need to pause your video to make sure that you have everything written down, go ahead and do so now. Number 4 says, using your number line to help, name the fraction equivalent to 20/6. Name the fraction equivalent to 12/3. Draw the part of the number line that would include these fractions below and label it. So first, let's work on 20/6. Okay, I see a 3 in the denominator part of the missing fraction, and I know that if I double 3, I'll get 6. So that means that 3 plus 3 is 6. That's where the 6 came from in 20/6. So if I double the denominator of that number and got 6, that means if I double the numerator, I should get 20. So what plus what would give me 20? You said 10. You're absolutely correct. 10 plus 10 equals 20. So that means that 26 is equivalent or equal to 10/3. Now moving on to 12/3. I see that the denominator is a 3, and I know that 3 plus 3 is 6, right? So that means if I double the 12, then I should get the numerator, the one that's missing. So what's 12 plus 12? Well, if you said 24, you're absolutely correct. So that means that 12/3 is equivalent or equal to 24/6. Now we're almost done. We just have to draw the part of the number line that would include these fractions below and label it. So let's go ahead and do that. So first I'm going to start off by drawing a little rectangle. All right, and I'm going to split that in half. Now the top of my rectangle is going to be in thirds and the bottom is going to be in sixths. And you're probably like, Ms. Jones, that's a small rectangle because we have 26 and 10/3. Well, you can start a number line at any number you'd like. And we're going to start our number line at a fraction that's closest to 10/3 and 26. And I'll show you what I mean. So first we're going to partition the top of this rectangle into thirds. 1, 2, 3. And the third line is on the end. All right, now I have to figure out what whole number or what fraction I need to start my number line with that's really, really close to 10/3. Well, I don't want to start it off with 3/3, right? I don't want to start it off with 3/3 because 3/3 is one whole. Now, if I'm counting by thirds, what third would be 2 wholes? What third would be 2 wholes? If you said 6/3, you're correct. 6 divided by 3 is 2, so that will be 2. That's still a little further from 10 than I wanted. Let me see if I can get a little closer to 10 using thirds. Let's see. How many thirds would be 3? What divided by 3 is 3? Well, if you said 9, you're absolutely correct. So 9/3 is the same thing as saying 3. Now that's really close to 10, right? So I'm going to start my number line with 9/3, which means I only have to go up by one fraction because third that would be after 9/3, 10/3, right? So I'm going to put 10/3 here, and I'm going to just shade from 9/3 to 10/3. See? Little bitty number line. Small. Very, very small. All right, now I'm going to partition the bottom into sixths. Remember, sixths are half of thirds. So put a line in the middle, one line directly below that one, another line in the middle, one line directly below that one, another line in the middle, and one on the end. Kind of hard to see, but it's there. All right, so equivalent means that it takes up the same amount of space. So how many of those sixths that I just partitioned at the bottom would I have to shade in to take up the same amount of space as that 10/3 that I shaded at the top? Right, right. I'd have to shade 2 of them, but first let's see what sixth we would start with, right? So I know that 6/6 is one whole, right? How many sixths would be 2? Well, if you said 12/6, you're right. That would be 2. All right, so that means that 3 would be, that's right, 18/6, which means I'm starting my number line at the bottom of sixths with the fraction 18/6. All right, so that means that I would have to shade 19/6 and 20/6 in order to shade the same amount. Very, very good. All right. Now, you might need to pause your video to make sure that so far you have everything that I have. Great. Now, I want you to create the exact same model on the other side. The exact same model. So it should look like this. The exact same model. I want you to create the exact same model. All right. So it needs to look the exact same, but this time we are going to be showing 12/3 and 24/6. Now we are going to start our number line off with the same exact fractions. So we're starting our thirds, the top part of our rectangle, we're starting our thirds off with 9/3, right? So if 9/3, 10/3, 11/3, 12/3. And we're shading 12/3. So we just shade that whole area, right? And our bottom is going to be 24/6. So if the whole top was shaded, then what's going to happen to the bottom? Basically the same thing, right? So we're going to start the bottom of our number line where the 6 are with the same fraction. We're going to start off with 18/6. And then we're just going to make little arrows to show that we're jumping to 24. So 18, then it would be 19, that would be there. 20 would be here. And I'm using arrows because it's such a small space. The numbers would get jumbled up if we wrote them. That would be 21, 22. So we're just showing the jumps. 23, 24/6 would be right there. And we just shade it all in. Now at this time, if you want to pause your video to make sure that you have everything on your paper that I have on my screen, go ahead and do so right now. Here we are at number 5. Number 5 says write 2 different fraction names for the dot on the number line. You may use halves, thirds, fourths, fifths, sixths, eighths, or tenths. So first thing I'm going to do with my very first model is look at the number line to see where my endpoints are. So I have an endpoint at 0 and an endpoint at 1. All right, I need to know what my numerator or my top number is. So my numerator is going to be where that dot is. So let's jump to the dot to see what my numerator is going to be. 1, 2. So my numerator is going to be 2. All right, now I jump from 0 to my first whole number to figure out what my denominator is going to be. So start at 0 again. 1, 2, 3, which means my denominator or my bottom number is going to be 3. So this model shows 2/3. Now, I need to figure out an equivalent fraction for 2/3. Well, that shouldn't be hard. As long as I use the double method, that should be great. It should be easy to do. So let's do our numerator. So 2 plus 2 would give me 4. And 3 plus 3 would give me 6. So that means an equivalent fraction for 2/3 would be 4/6. Let's move on to the next model. I see my endpoints are 0 and 1. So I'm going to start at 0 and go to the dot to figure out what my numerator is. 1 jump. So that means my numerator or my top number is a 1. Now I'm going to go from 0 to my endpoint of 1 to figure out what my denominator is or my bottom number. So that's 1 jump, 2 jumps, 3 jumps, 4 jumps until I get to a whole number. So that means I'm counting by fourths, which means my denominator is a 4. My fraction represented by this model is 1/4. Well, now I have to find the equivalent fraction. Well, that's easy. So I'm going to take my 1 and I'm going to double it. So that means I'm going to say 1 plus 1. Well, what is 1 plus 1? If you said 2, you're absolutely correct. And then I do the same to my denominator. What is 4 plus 4? If you said 8, you are absolutely correct. So that means that 1/4 is equivalent or equal to 2/8. Now we're going to move on to our third model. And I look at my number line and I notice that my endpoints are 1 and 2, which means we're not starting at 0. So let's go ahead and figure out what our denominator is first. So from whole number to whole number, if we count our jumps, that will give us our denominator. So let's see how many jumps we have. 1, 2, 3, 4. So from 1 to 2, that's 4 jumps, which means we're counting by fourths. So that means that our number line starts with 4/4. And 4 divided by 4 is 1, so that's correct. Now I'm going to just label my number line to figure out where their dot is. So we start with 4/4. So next would be 5/4, 6/4, 7/4. So that means that the fraction that's represented by this number line is 7/4. So I circle my 7/4 and then I'm going to write it on the line. Now to find the equivalent fraction, I just double my numerator and double my denominator. So let's double my numerator or my top number first. What's 7 plus 7? If you said 14, you're absolutely correct. And let's double that denominator. What's 4 plus 4? That's right, it is 8. So that means that 7/4 is equivalent or equal to 14/8. Now let's move on to our final model at the bottom. And it also starts with 1 and ends with 2. So let's start at 1 and jump to 2 to find out what our denominator is. What unit fraction are we counting by? So let's see. 1, 2, 3, 4, 5. So it's 5 jumps from 1 to 2, which means our unit fraction that we're counting by is fifths, which means our number line starts with 5/5. Now let's go ahead and label all of the lines on our number line so that we can figure out what fraction is represented by that dot. So we'd have 6/5, 7/5. That means our dot is 7/5. I keep numbering 8/5, 9/5, 10/5, and I'm going to circle where that point is, or that dot is on my number line. All right, so on my lines, I'm going to write 7/5. Now I need to double it to figure out the equivalent fraction. So what is 7 plus 7? If you said 14, you're absolutely correct. And let's double our denominator now. What's 5 plus 5? If you said 10, you're absolutely correct. So that means that 7/5 is equivalent or equal to 14/10. Now, at this point, if you need to pause your video to make sure that you have everything written on your paper that I have on my screen, go ahead and do so now. Number 6 says, Daniel and Mandy each ordered a large pizza for dinner. Danielle's pizza was cut into 6, and Mandy's pizza was cut into 12s. Danielle ate 2/6 of her pizza. If Mandy wants to eat the same amount of pizza as Danielle, how many slices of pizza will she have to eat? Write the answer as a fraction. Draw a number line to help explain your answer. Okay. When comparing fractions, I love drawing rectangles because it allows me to line everything up. So let's draw a rectangle and split it in half. All right, so the top's going to be for Danielle and the bottom's going to be for Mandy. All right, so it says Danielle's pizza was cut into 6 and Mandy's pizza was cut into 12s. All right, so let's cut Danielle's pizza into 6. So I like making a line straight down the middle, okay, to make my parts even. All right, so let's make a line straight down the middle. And then let's go ahead and partition the top into 6. So making a number line, right? 1, 2, 3, 4, 5, 6. All right, now notice I went ahead and I put my endpoints of 0 and 1 there because it's supposed to be a number line. So let's take a moment to go ahead and make sure that the top of your rectangle is partitioned into 6. Okay, and that you have a 0 and 1 at your endpoints. Because even though this looks like a fraction strip, you can always turn a fraction strip into a number line by adding endpoints, which is what we did. Now, we're going to go ahead and label our 6. So go ahead and start by labeling 0/6 above the 0. And on each line, that would be a 6, just like with a number line. So we have 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. All right, and Danielle ate 2/6. So we shade in 2/6. All right, now we've modeled Danielle, the amount of pizza that she ate. Now we have to model Mandy, and we have to split the bottom into 12s. Now remember, 12s are half of 6. So you should have a line in between each 6 and a line directly under each 6. So let's go ahead and partition the bottom into 12s. 12s. That's 1 12, 2 12s. Notice how that's directly under 1/6. The next one's in between. The next one's directly under 2/6. The next one's in between. And see how that center line's already there? Okay. The next one's in between. The next one's directly under 4/6. The next one's in between. The next one's directly under 5/6. The next one's in between. The next one's directly on 1. See that? All right, now, says if Mandy wants to eat the same amount of pizza as Danielle, how many slices will she have to eat? Well, let's label our 12s. So where that 0 line is, we're going to mark 0 12s. And we're going to label the rest of our 12s. So let's go ahead and label 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s, 8 12s, 9 12s, 10 12s, 11 12s, 12 12s. Now take a look at Danielle's model, right? Now look down at Mandy's. How many 12s would you have to shade in to equal the same amount of sixths that Danielle's model shows? Now, if you said 4, you're absolutely correct. Look at that. We had to shade it in 4 12s to be equivalent or equal to 2 6. Now, the instructions say to write the answer as a fraction, draw a number line to explain your answer. Now, we completed a number line to explain our answer, and let's go ahead and write it in words. Now, in words, we would write Mandy would have to eat 4 slices of pizza or 4 12ths of her pizza if she wants to eat the same amount as Danielle. I see that 2 6 is equal to 4 12ths. Now, if you need to pause your video to make sure that everything on my screen is on your paper, go ahead and do so now. Congratulations! Lesson 24 homework is complete. As always, I hope this video has helped you to complete your homework correctly and help you to understand lesson 24 a little bit better. And with math, please make sure to check your work because you have to be sure that your math is mathing. Now, until next time, this is Miss Jones saying bye. Have a good day or night whenever you're watching this video.